So here it is given, and for this question I'm going to draw my own set of this axis. Okay, so y is x. So it is given that point T is graphed at 13 comma 5. So let's say this is 13, this is 5. Okay, point T somewhere here, 13, 5. Okay, now point R is located at 1 comma 0. So here somewhere is point R, 1 comma 0. Now it is asking that for what coordinate of Q which is lying on the x-axis. See, Q is lying on the x-axis, so Q would be lying somewhere here. So for what value of the x coordinate of point Q, the area of triangle TRQ is going to be 45. So say for example, Q is somewhere here, okay, x comma 0. Now if you are going to make out a triangle TRQ, then we already know what the height is. What is the height of this triangle?
13. Wait.
No. This is the height, right? So this is 5.
Yeah.
The height is equal to 5. So area is going to be equal to half into height is 5, and what is base? What is this length?
X minus 1.
X minus 1 it is. So this is equal to what? 45. When you are going to solve this down,
Oh, okay.
answer which you are going to get is x is equal to 19. Answer.
Okay.
Option D. Okay. Any doubts?
Yeah, I was trying to do some like random formula to find the area.
Like you are trying to apply the Hero's formula by calculating the length of sides using the coordinate method.
I was using like a formula. It was like 1/2 into x1 times y2 minus y3 plus x2 into y3 minus y1, something like that.
Yeah, so like that formula, under root x2 minus x1. Yeah, there was a formula like that, but yeah, I think you're trying to find out the determinant using that formula. That formula under root that can also be calculated out using the determinant method. Here you are just going to write x, y, z coordinate 1 x 13 0 0 5.
Yeah.
You know how to find determinants?
Well, what was that?
Okay, no problem. Like that is just an like a more matured up way you can say to like find out the same formula that you're trying to apply.
Okay.
Student. So the larger circle shown has center S and the smaller has center W. So this is the center S and this is the center W. Okay. Now yeah, and radius WS. This is okay. So WS is the radius. It means like this is the point S. This is not the point S. This is the point S. Exactly at the boundary of the circle. So R, W, S, and T. This is point S. Okay. So if WS is the radius, then it means what? The circles are internally tangent at R. R, W, S, and T are collinear. Yeah. Also, if all the 4 points are collinear, it means this is making out a straight line right here, right? And this straight line is also passing through the center of the bigger circle. It means this RT is also the diameter of the bigger circle. Okay. Now, uh, yeah, if U and T are on the circle S, okay, RU intersects circle W at V. Okay, this point V. Now, if UV is equal to 4, if UV is equal to 4, if ST is equal to 6, so if ST is equal to 6, these will be 3 3 as you have marked here also. Okay. Now we have to find the length of UT. Okay, UT we have to find out. So as we can clearly see that this is the diameter, so this is 90 degree. Okay, very good thing that you have marked this here. Now if this is the right angle, then hypotenuse we also know the hypotenuse length is equal to 12. We just have to find out this whole length, or rather I should say this is also known. We just have to find out RV, and then we'll be having this length. Okay, so what we are going to do here is we are going to make a construction something like this. We are going to join S and V. Okay, and this is also going to be 90 degree. Why? Because this is the diameter of the
Similar.
smaller circle and we are making a triangle out of that. Okay, this is also going to be 90 degree. Now, what is there to remain? Only thing that is there to be applied is that Thales theorem. Okay, which says that triangle RVS is similar to triangle RUT. Okay, by angle criteria, angle similarity. One angle is common, right? And because these two lines are parallel also, or we can also say that in these two triangles, one angle 90 degrees are equal, and this angle R is common. Okay, so by angle similarity, they would be similar to each other. So RV upon RU would be equal to RS upon RT. Okay, so what is RV? RV is unknown. Let's say it is X. What is RU? RU is X plus 4 is equal to RS. What is RS? RS is
6,
6. What is RT? It is 12.
12.
Okay, sorry, 2 times. So it will mean that X would be equal to 4.
4, yeah.
Okay, this is 4. Now, in the right angle triangle RUT, the perpendicular is 8. The hypotenuse is 8. So UT would be equal to under root 144 minus 64. It
80.
means under root 80. It means 4 root 5 is going to be the final answer. Okay,
Okay.
option D. Okay, this thing has got to be noted that like application of Thales theorem, especially I have seen multiple times that you're having a bit of hard time applying it. So yeah, keep this theorem in your mind that similarity property of triangles is going to solve many problems for you. So you have to keep
Okay.
always these things in mind. Okay, the similarity property is very, very, very important.
All right.
To the next one.
Okay.
So here GHJ is an equilateral triangle. Okay, this is an equilateral triangle. Now the semicircle uh, shown has a diameter on HJ, okay, the semicircle, such that these two sides, GH and GJ, are tangents to the circle at points K and L respectively. Okay, so if HJ is equal to 1, if this whole thing is equal to 1, then find the area of triangle GKL. Okay, this triangle's area we have to find out. Okay, so first of all, let's assume this point I to be the what? Like center of the semicircle, okay?
Mm-hmm.
Now, if we are going to join a radius something like this,
It's perpendicular.
exactly, this will also be perpendicular over here. Now let's join points K and L as well.
Okay.
Okay, now as we can see in these two triangles,
30, 90, 60.
just a second. First of all, yeah, first of all they would be congruent to each other, right?
Yeah.
Angle, angle, side, radius. Okay, by this property they would be congruent to each other, and if they are congruent to each other, then HI would be equal to IJ. It means this point is lying
The
just
center.
below this vertex. Yeah, it means there is absolute symmetricity with respect to the point I, because this triangle is again equilateral. This is median also, this is 90 degree also, this is angle bisector also. Okay, now one thing has been found out. Now, if this angle is 60, this angle is 30. Okay, now there can be many methods to try out find this question, but the ideal one would be, since we know this length is equal to 1 upon 2, and we know all the angles in this triangle, so can we not apply this formula that this radius over here, or not, let's say not even this radius. So first of all, what we have found out that these two triangles are congruent to each other, right?
Mm-hmm.
So just a second, if these two are congruent to each other, then how can we prove that this is also parallel to this? If this we have proven out, then half of the question would be solved. Just as it is.
I think we have to like because it's like actually never mind.
Okay, wait a second. If these two angles are 30, 30, something like this, then
Yeah.
this whole angle would be 120, right?
120.
And
And then you
again,
can
this
split it in
triangle
half.
KIN, yeah, this is an isosceles triangle, radius,
Yeah, with side
right?
lengths root 3
So
over
yeah,
4.
so this would be
Root 3 over 4.
no. This angle would be,
Oh, 30.
and this angle would be.
30.
Let me zoom in. Okay. So as we can clearly see that this angle is equal to this angle between these two lines. It means we have proven out that these two lines are parallel to each other. Okay. And
Yeah,
if these
okay.
two lines are parallel to each other, then triangle GKL is also an equilateral triangle. Okay.
Yeah.
So let's say the side lengths are equal to x. Okay. And so this would be what? 1 minus x.
Yeah.
Right. So in this triangle, when we say that 1 minus x, 1 minus 1 minus x is equal to nothing but half cos 60 degree.
Mm-hmm.
Yeah. This sides, this angle component, cos component would be equal to this, right?
Number 4. Yeah.
It means x is equal to 3 upon 4, right?
Yeah.
It means the side length is known now. So the area is just going to be equal to what? Root 3 by 4 into x square.
So it's 9 over 64 root 3.
9 root 3 over 64. Okay, answer. So option A would be correct. Okay.
Okay.
So the main thing was to like absolutely we know that because there is a semicircle and we all know that circle is a symmetrical figure. Especially there would be all-round symmetry if it is inscribed in an equilateral triangle like this. But still, in order to like use this property that this triangle GKL is going to be equilateral, we had to like double check that if our assumption is going to be true or not. That is why this proof was also like an important part of the whole thing, that proving out that this whole triangle GKL is also going to be equilateral. Okay, and then when we have proven it, what was the like yeah, this 1 minus x we have found out because we had to find x. Now that is only what is going to give us the side length which would be needed to find out the final area that is required. Okay,
Yeah.
any doubts in this one?
No.
Questions are finished now. Now we are going to continue our discussion. 3D geometry. I guess up until frustum we have done. Yeah, the formula derivation for frustum. And one question also we did. Is that right?
Mm-hmm.
Okay, just a second. Hmm, yeah, okay. Okay, now we'll continue with the questions only. So, what is happening? Lecture one. No. Where is the page of our current discussion? Okay, to find it out. Where the page gone?
Isn't it the one right before it?
Yeah, this is the one. We are currently on it.
So 5, I think.
It was sixth for the whole month. Okay. Let's start. So, inserting the question. Yeah, let me insert it. I have to open the PDF also. The fourth